Welcome to 5G Hub. In this video, we will talk about the RAN evolution towards OpenRAN. Most mobile network operators today are built with a DRAN or classical RAN architecture or the classical RAN network architecture, whereby the baseband unit or PPU and remote radio unit RRU are co-located as a cell site, typically in a cell site cabinet near or at the base of the tower. In the first approach or first traditional generations of macro base station, the radio frequency transmitter and receiver electronics are located at the base of a tower or in a building, and the large diameter coaxial feeder cables are used to connect the electronics and the antennas. So here the RRU is located with the PPU in the cabinet. The cell sites are then connected to the evolved packet core in 4G, for example, via backhaul transport links. In a second evolution, distributed RRH appears. The RRH or remote radio head contains RF transmit, receive components including power amplifier, duplexer, low noise amplifier, etc. And they can be mounted directly on the antenna mast. Those only short coaxial jumpers are used for the connection to the antennas. Due to their lower capex and opex, these RRH are currently being deployed not just for new technologies like LTE and LTE Advanced, but also in new and replacement infrastructure for older technology 2G, 2.5G, 3G. The RRH can be linked to PPU or baseband unit by an optical single-mode fiber using a standard interface with a digital radio signal such as a CPRI or Common Public Radio Interface. Transition to Centralized RAN or CRAN architecture. The next logical step is to move the PPU to a central office. This logical step is possible due to the fact the optical fibers are available between antenna site and central office. This fiber availability is in relation with the fact that traditional backhaul architecture in the previous evolution will need also fiber. So in any case of evolution, the most part of the antenna site will be connected by fiber. This evolution step is called PPU centralization, where PPUs of different base stations are co-located in the same central office. Generally, with PPU stacking, there is one PPU that handles at all RRH located as a cell site, and the PPU can communicate with each other within the PPU hostel or hotel via standardized X2 interface. Now, if you are talking about the next step is virtualized or cloud RAN or CRAN or vRAN. Virtualized RAN overcomes the limitation of CRAN by leveraging virtualization. So the virtualization RAN architecture is virtualized PPUs running on general purpose hardware in mobile data centers or at the cell sites or other network edge data center and RRU located at the cell site. So virtualization enables a new function splits in the RAN elements, which relaxes the requirement for front-haul transport and increases the distance that V or virtual PPU can be located from the cell site to up to 200 kilometers. Now transition from vRAN to OpenRAN. What is the key with OpenRAN? The key with OpenRAN is the interface between PPU and RRU or RRH is now open interface. So any vendor software can work on any open RRH or RRU. So more open interfaces, this will enable one supplier, radios, and another processor, which is not possible with CRAN or vRAN and limited for proprietary hardware, for example, or proprietary software. So OpenRAN is a disaggregation of hardware and software. So the RRU, for example, hardware becomes COTS hardware or common on-the-shelf hardware that can be purchased from any RAN hardware vendor, for example, vendor A. And the PPU is the same as in the case of vRAN, a cost server or common on-the-shelf server, and the vendor proprietary software with a virtualized function. So this is the route starting from DRAN to OpenRAN. We are supporting in OpenRAN openness and intelligent using AI and machine learning. So thank you for watching and see you in next video.